Hi, I'm Alex Hutchins, and this is my Challenge 2 demo for ECE461. The assignment is to make a home monitoring system with a watchdog timer. So it has a doorbell, a burglar alarm, and a fire alarm. And it's implemented on a MSP432 with the educational booster pack. The user interface has the following requirements. Each time that the doorbell is pressed, it has to emulate a doorbell sound for 2 seconds. When the other button on the booster pack is pressed, it activates or deactivates the burglar alarm, and it's indicated by a green LED for deactivated and red LED for activated. The burglar alarm status has to be initialized to deactivated. When a sound threshold is passed, the burglar alarm will sound. And when a light threshold is exceeded, the fire alarm will sound. And the fire alarm has to sound with priority to all other functions. In this video, I will show the device working with outside of debug mode. I will then show it working in debug, and I will explain my code, and I will demonstrate one static analysis, one dynamic analysis, one pre-compile optimization, and one code implementation optimization. We'll begin with the real-time demonstration of the device. First, we'll start by powering the device by plugging in the USB. Notice that the alarm status is green, which means deactivated. So first we will sound the doorbell. Notice that was for 2 seconds. Next, we will show the burglar alarm. And see that the red LED changed when I pressed the button to show that the alarm was activated. Then with a button pressed, it deactivates the alarm, and then it changes the status to green. Alright, and notice that the alarm will preempt the doorbell. And when I press the doorbell, it doesn't go off. And to show that it better preempts it, I'll go ahead and set the alarm and then sound the doorbell. And notice that the burglar alarm stopped the doorbell. Next, we should show that the fire alarm preempts everything, which I will go ahead and sound the burglar alarm, and then shine a light. And notice that pressing the doorbell doesn't do anything, and the burglar alarm won't sound either. And it cut off the burglar alarm. With the fire alarm still sounding, notice that the watchdog timer is being reset, and so the system isn't being reset, and that the only way to stop the fire alarm is to perform a full system reset. So now we'll start the software part of the demo, and we will begin with the static analysis, and we will be using Optimizer Assistant. So this will show the speed versus the size, and it'll lead us into our pre-compile optimization setting. So by using the optimizer assistant, you press play and just hit start. Okay, with it finally done, we can see the various trade-off, and with optimization level 2 being the in-between point, which we will choose. Now we'll implement this by going to build settings, optimization, level 4, leave that, and we'll switch that to 2. And this can actually stay off. And now we will build it and go to device. Okay, here's the optimization advice that it gave. I set it to 2. It says the best is 5, but I wanted a trade-off, an equal trade-off. Next is the power, but these are just I'm ignoring, and these, however, that uninitialized ports are an error because I actually implemented in the code, which you'll see under my init file. Initializing all the ports and setting and underneath my ports file, sorry. You can see that I set all the pins to output low, and so that's what TI suggests, but for some reason it still gives me the advice to initialize them. I don't know why. The main code is pretty simple. Initialize the system and then run the scheduler. Showed you the function for initializing the system, which just initializes all the ports, initializes the reference for the comparator, initializes the timers, the light sensor, the ADC, adds my periodic tasks, which is watchdog timer reset, read light, check burglar alarm. That's a typo. Should be a sample ADC, check doorbell, and then initialize the systic, which is used for the scheduler, NVIC, which is the interrupt handler, and then the watchdog timer init. So we'll close out of that, and then so the next thing in main was to run the scheduler. So if I go to RTC schedule.c, that is the tick ISR, the systic ISR, which I said was used for the scheduler. Running the scheduler just is a it always occurs. That's why the main doesn't have a infinite while loop, because it's run in the scheduler. And then this is a for loop, which just goes through the task table and then implements all the tasks. And afterwards, it puts it into a low power state before running the next loop. So going to wait for interrupter goes to low power mode 0, and this is the implementation for optimization. And then next we'll now load the code onto the board. So you can see it loaded. So next we will perform, let's see, we already, so next we will perform the dynamic power analysis. We'll use energy trace. We can start energy trace, and then we'll start our device, and then we will go to the power graph, so this is just showing the watchdog timer. Notice the square wave going with that, so maybe I can try and get both. So when the power goes high, it's when the LED is being turned on, and when it goes low, the LED is being turned off. So we can stop this by going back to energy trace, stop. We'll minimize that. Next, I'll just go through the rest of my code. Watchdog timer init simply, initializes it to be every second. Watchdog reset simply clears it. ADC code, sampling the ADC, which is a periodic task. And for the ADC, I'm using the comparator, so it only it will only detect a pass, a high threshold pass, and that's just to make it simpler, so I don't have to run any other comparison. The ADC automatically does it using the comparator, makes the code simpler and run faster. Next, we'll look at check the light, read light, and so that just uses the built-in function or the example function, and looks for if it's above a threshold, and then sounding the alarm is just checking which sound pitch it needs to produce. And of course, this is going to be an infinite loop. I don't use this variable stop, so this is unnecessary. But so that'll just cycle through. A sounding buzzer will just is a function that calls a timer, and then it does and the buzzer is set up through PWM, and so one is the period of the PWM pulse, and the other is just the period of the actual sound. So next we'll go to burglar. So sounding the burglar or checking check burglar is a periodic function, and it adds the task of sounding the burglar alarm and changes the status. It checks a global variable, which was that's indicated through the ADC. The ADC interrupt will allow this to occur in the conditional statement. Then the sounding the burglar alarm is pretty much similar to the fire one, except for at the end, it changes a variable to it changes the alarm status, which will then cause it to go into this if statement and then cancel and remove the task from the scheduler. Likewise for the doorbell, it checks the doorbell using a global variable, and from the doorbell interrupt or the button interrupt, it'll change the status of the variable, and then so that the sound doorbell task can be added to the scheduler. And then this one has 4 different pitches. 2 of them are the same. That's why it goes high, low, high, low. And just to implement this again, we can see. And then so likewise, it'll at the very end it changes it to changes the variable to enter this if statement to cancel and remove the task.